Our group 5. Today we're going to explain some questions about planes and curves. We start from the first part of question 1. The question 1 is about how to determine whether a plane curve is a regular curve or not. The property of regular curve is that the norm of its first derivative is equal to 1. So to determine the question, we first find the first derivative of gamma, which is shown on the screen, and then we find the norm of it, which is equal to the square root of sine t squared. As square root of sine t squared is always greater or equal to 0, so we need to find the at that it makes the square root of sine t squared always be greater than 0. The t needs to be in an open interval, which is from 2k pi to pi plus 2k pi. And for some special case that when t is equal to pi over 2, and in this case sine t is equals to 1, and therefore the norm of the first derivative of gamma is equal to 1, and in this case gamma is a unit speed curve. Then we need to find the unit speed reparametrization of gamma. We first find the arc length s, which is equal to the integration of norm of the first derivative of gamma, and the exact value is shown on the screen. Then we need to find the inverse of s, which is equal to cosine of minus t to the power of minus 1, and it is equal to phi t. And by the definition of reparametrization, gamma Twitter is the gamma of phi of t, and the value is present on the screen. And by some calculations, we can find it is equal to 1. It shows that the curve does have a unit speed parametrization. Then we move to the second part. We need to calculate the curvature and the sine curvature of gamma. For regular curve, it's n equals 2, the formula of curvature as shown on the screen. And by some calculations, we can find the exact value of it. And the sine curvature has the same absolute value as curvature. The only difference between them is sine curvature has a direction, and in this case sine curvature is positive, so it is equal to the curvature, which is equals to 2 divided by square root of sine t squared.
By definition, in mathematics, curvature is any of a number of loosely related concepts in different areas of geometry. The sign of the signed curvature k indicates the direction in which the unit tangent vector rotates as a function of the parameter along a curve. By our sample, we can see that we have the same signed curvature and curvature, and we also can see that we have the same curvature at both sides of y-axis, so we may assume that we will have a curve which has the same graph on both sides of sine curvature. And we can see from graph that we do have a graph which has the same features on both sides of y-axis.
And on this question 2, we need to test if the gamma is regular or the unit speed curve. And according to the formula, the norm of the first derivative of lambda, and after the calculation is equal to 1, so we can say the lambda is regular. And additional, the norm of the first derivative lambda not equal to 0 but equal to 1, so we can say the lambda is the unit speed curve. So there is not the parameterization of the unit speed, and also by the definition, the creature of the lambda is defined by the norm of the second derivative of the lambda.
By definition, the torsion of a curve measures how sharply it is twisting out of the plane of curvature. Taken together, the curvature and the torsion of a space curve are similar to the curvature of a plane curve. And by the formula of curvature and torsion, we can get results like this.
Here is a graph of number 2 questions like this. Then come to the question 3. It's about the fundamental form. For the first fundamental form, it always has two normal types. The first one is as a matrix. It's always marked as the Roman numbers 1, and this other one is the 3 coordinates. Before the calculation, we need to do preparation. And after the calculation, we find the first fundamental form like this. And for the second fundamental form, it's similar with the first fundamental form. It also has two types. The first is as matrix and marked as Roman number 2, and the other type is 3 coordinates. For the Gaussian creature and the main creatures, by the definition, the Gaussian creature equals to K1 times K2, and the main creatures is equals to K1 plus K2 divided by 2. And the K1, K2 are the two eigenvalues of A, and A we call the shape operator, which equals to the inverse function of the Roman 1 times the Roman number 2. Then here is a graph for the question 3. It's like this.